Yes, so we said we want to look at this important difference, which is molecular compounds versus ionic compounds. Now, let's see. Remember that they are chemicals. They are chemical compounds, right? Now, what is a molecular compound or a molecular chemical compound? Well, it is a compound that is made up of discrete units that are called molecules, okay? That are called molecules. So let me slide in a bit like this. Okay, it is a compound that is going to be made up of discrete. When we say discrete, we are saying they are separate, identifiable units, stand-alones. A molecular compound is made up of separate units. We have unit 1 and another unit here and another unit there, which stands alone. It stands alone. It is not bound. It is its own thing. Okay, so it is made up of separate, identifiable units, something that we can actually take and look at and analyze, okay? It stands alone. And that is what makes up a molecular compound. It is made up of molecules. And what are these molecules? They are separate, identifiable units. That is why we call it a molecular compound. It is made up of molecules, okay, which are separate, identifiable units. They are discrete, which means they are separate. Each molecule is made up of atoms from 2 or more different non-metal elements. So each molecule will be having 2 or more atoms together. And these atoms will be from either the same element or from different elements. So it is not always different, but they have to be non-metal. So I'll kind of do it like that. Okay, but for it to be a compound though, it has to be different elements. But although you can find a molecule in elementary state like O2, this is a molecule because it has 2 or more atoms. But, okay, so molecules can be for compounds or for things that are not compounds, for elements. As long as you have 2 or more atoms, you call it a molecule. But anyway, for this situation, we'll be having 2 or more different non-metal elements coming together, and they have a covalent bond. They'll form one molecule. So one molecule will be having 2 or more atoms that are covalently bonded together. That is one molecule, a standalone unit called a molecule. Inside it, you have 2 or more atoms that are covalently bonded together, and that is what we will call a molecule. Now, a molecule is a representation of the compound. Do you know why? Because your molecule will have the same chemical and physical properties as the compound. So if you have a whole dish or box of something, if you go into it and take, let's say this box has or whatever, maybe water or whatever. If you go into it and take one molecule of that substance which is inside, it will have the same properties as this whole dish full of whatever you be having. Could be water. So let's say it's a bucket full of water. If I can take one molecule of water, it's going to have the same boiling point as this whole dish. That's what we're saying. So a molecule has the same properties as that compound that it comes from. Okay? Here's what we are just trying to say, people. Here's what we are trying to say. If something is molecular, then it is made up of separate parts that are just linked, but they are not attached. Okay? They are linked. So this bonding, what joins this green stuff that is joining 2 molecules. This is a molecule. You see, I'm circling the molecules. What joins these 2 molecules is not the covalent bond. No! Covalent bond is, let me choose a black crayon or purple. Covalent bond is this one which I'm putting in purple. That is between an oxygen, your O, and 2 hydrogens here inside a molecule. So it is an intramolecular bond force. It's a fundamental bond. This covalent bond is between hydrogen and oxygen. But this green stuff here is not covalent. This is not covalent bond. Okay. In this case, it is hydrogen bonding. It could be van der Waals forces or whatever it is, but it is not the covalent bond because these things are not chemically bonded. Molecules are separate. They exist alone because if they were bonded, that means they should be one thing. Because if you're bonded, you become one. But these are not bonded. These molecules are alone. They exist alone. They are discrete. They are separate. That is your molecular compound. So I know in water, I have many H2O molecules coming together and they are not chemically bonded, but they are together, and that is what makes me have a whole lot of water. They are separate though. They are separate identifiable units. In one molecule right now, I've seen that I have 2 hydrogens and 1 oxygen. That's why we say H2O. And this is what? 1 molecule of water. That's 1 molecule of water right there. Okay, now let's see what an ionic compound is, and let's see what big mistake people make a lot. An ionic compound now, instead of being separate, okay, what is it made up of? It is made up of a repeating pattern, a 3D pattern, which means it goes in all directions. 3D pattern, a repeating 3D pattern or repeating lattice, a lattice of positive and negative ions. A 3D lattice. What is it? Let's see what a lattice is. Let's go through this, right? When we say it's a lattice, it's something, it's a very special pattern, a 3D pattern. That's a lattice. Okay, we'll be having a 3D pattern. So what is it? Instead of, basically, I don't want you to think about it as something complicated. When we saw a molecular compound, it was just made up of molecules that are separate, right? And they have a weak attachment. They are not chemically bonded. The chemical bonding is inside one molecule, where we saw that we had an oxygen bonded to hydrogen and bonded to another hydrogen. That is the covalent bond, this one. The one from oxygen to hydrogen, and which is inside the molecule. But to now come from, yes, oxygen had to bonded to hydrogen but to now come from molecule to molecule, the bonding which I'm putting in white, this one, is not covalent. It will be some other type of bonding, which is not a chemical bond. So it's not something that makes them one. No, this one is going to be alone. It's a molecule that is going to exist as a separate unit. And this guy will be alone, but they'll just have some weak attraction that makes them stick close to one another and be like that. Okay, and that is why they have some of the properties which they have, like low melting point, low boiling point, is because they are not strongly attached. But when we come to ionic compounds now, what makes them ionic is, number one, they are made up of a 3D pattern of ions. It's ionic bonding because it's ions that are bonding. Okay, it's ions that, and this is something very important. Very important. I'm explaining to you when we get to the diagram right now. But we are saying it is positive and negative ions that are joined together in a 3D pattern. You have ions joined together, positive and negative ions, joined together in a 3D pattern, okay, by ionic bonds. The bond between a positive and a negative ion is called an ionic bond because it's a bond between ions. It's between ions. The bond between Na plus and Cl minus, this bond between them is the ionic bond because it is a bond between ions. What makes them ions, these guys, is that they've lost an electron or gained an electron. If you lose or gain electrons, you become an ion. You either become positively charged or negatively charged. There is no way you're going to lose an electron as an atom. If you take a sodium atom, and you make it lose an electron, it's going to become an ion. Or gain an electron, it's going to become an ion. ION, okay, not ion for ioning, but it becomes an ion because it has lost or gained an electron. Now, when you have a positive ion and a negative ion together, they have bonding between them, which is a chemical bond, and that bond is called ionic bonding, which makes them one. So these are not separate, they are one. They are one, okay? So they have, and that is an electrostatic force of attraction. By electrostatic, we mean it is between charges, okay? A positive charge and a negative charge. That is a chemical bond, ionic bond. It's an electrostatic force of attraction. Electrostatic, why is it electrostatic? Because it's between opposite charges. Now, in its look at this, what happens in the lattice. Each ion is surrounded by and bonded. This is the important thing. It is bonded to ions of opposite charge. They become one, and this creates a continuous network of ionic. So they are not separate, but it is one, a continuous network. It is, you have an Na plus, some positive guy is going to be surrounded by negatives, okay, on the inside and outside. So if we go this way, up and down, it's negative. If we go right to left, it's negative. If we go inside to outside this way, this is positive, negative. Look at him. He's surrounded inside, outside, up and down, right to left. Oh my gosh. that is what we'll call an ionic bond. Okay, it is each ion is surrounded and bonded to ions of opposite charge. So unlike molecular compounds, which have discrete molecules, ionic compounds do not have discrete molecules. They have nothing called a molecule, which is something that exists on its own. No, that will never happen. But they have a continuous pattern of ions. Here is an example of the structure. Look at it. You have this, which one should we pick? Either one that we pick. Let's pick this guy here. Look, if we go up, we meet a negative. If we go down, we meet a negative. If we go from left to right, we meet negatives. If we go inside to outside, we meet negatives. Can you see he is surrounded? He is surrounded by guys of opposite charge. And they are bonded. That's important. There is a bonding here, which makes them one. Look, that's what they keep doing. This negative, if you go in all directions, he is going to be surrounded by positive guys. If you go down, he's surrounded by another positive, which is here. If you go down and if you go up, there was another positive here. So he is surrounded completely by ions of opposite charge and bonded to them. And this is an example of a lattice. That is what we call a lattice for an ionic compound. So what makes it be an ionic compound? Instead of having separate things, it has the things being one. They are not separate entities. They are together. So you say to me, if they are together, what makes us call it NaCl? Are you telling me that this thing has one Na and one Cl when I have so many Na pluses and so many Cl minuses? Because you know what happens in ionic bond? You'll be having an Na, you'll be having a Cl. These are atoms. Then sodium, to become stable, it has one electron in its last shell. It doesn't need that electron. It's going to throw it away. Then it will remain stable. But when it's stable, it will now have a charge. It is stable. It means it is no longer reacting. It's no longer chemically reactive, but it is now charged. Cl will accept, become Cl minus. It also will become charged. Once they have different charges, then they will attract, and that is your ionic bonding. So ionic bonding happens after sharing. It is not the sharing that causes that is ionic bonding, but sharing causes ionic bonding. Transfer of electrons. When it comes from sodium to chlorine and chlorine becomes negative, sodium becomes plus. The transfer is not the bond. Transferring an electron is not a bond. The bond comes because an electron has been transferred. After. So when I transfer an electron, I now become an Na plus. When he gets the electron, it becomes Cl minus. But the bond is not yet there. I've just transferred. Now, after transferring, we now have different charges. Then we will attract and bond and become one. So there's a chemical bond. That is a chemical bond, right? Okay, that is one thing. And that is what we call by an ionic thing. It is going to be continuous. So please, I know you used to think that ionic bonding, we had an NaCl somewhere, and then it was bonded to an NaCl somewhere. Then it was bonded to another else NaCl. But that is wrong. That doesn't happen for non-metals. It doesn't happen. In ionic bonds, when you have a metal and a non-metal, no, that won't happen. We have Na plus, and around him is going to be Cl minuses. Cl minus here, another Cl minus there, another Cl minus there, another Cl minus there, another one in front, and another one at the back. So we'll be having a bond like that going this way, one going like this, one going like that. These are the bonds that we will be having. It will be surrounded by Cl minus. That is what happens. It's different from molecular where you have molecules. Please make sure you have mastered that part. So for ionic compounds, we don't have them as separate, but they are one. It's a continuous chain. It's a 3D lattice. It is not molecules that are separate. They are not discrete, but they are one. And that is the last important part. We'll see you in the next video where we talk about more things. Okay? Bye for now.